Today we're going to talk about the horizontal asymptotes of rational functions. So let's say we have a horizontal line, y equals b. In our case, we're going to make it the line y equals 0, which is, of course, our x-axis. So let's draw this line y equals 0. And what it's saying is this function, as f of x approaches b, in this case, as f of x approaches 0, notice that as f of x, as x keeps getting larger, f of x is getting closer and closer and closer to 0, but never reaches there. So as x approaches infinity, f of x is closer to 0 in this case. It could be to any line y equals something. We could give you another example in a minute. And this would also be true for negative infinity. If I were to trace this graph out as x gets smaller and smaller, notice how it's getting closer and closer to y equals 0, but never quite gets there. Therefore, that line y equals 0 is called an asymptote. Let's put it in red so we can kind of see y equals 0. Now that line y equals 0 doesn't have to be there. For example, I could draw another graph. And let's say I had a line right here. Let's say at 1. And let's say this function were to get closer and closer to y equals 1, but never gets there. Therefore, that line y equals 1 is also an asymptote. Now, we need to learn about these horizontal asymptotes for rational functions because we're leading towards graphing rational functions. And in order to graph them, we have to know if they have any horizontal asymptotes or not. So let's go to the next board. And with rational functions, there are ways you can tell if they have horizontal asymptotes. It turns out that if the degree of the numerator is larger than the degree of the denominator, then there are no horizontal asymptotes. So if the degree of the numerator is greater than the degree of the denominator, then there are no horizontal asymptotes. Well, let's look at an example. So here's an example, and if you notice in this case, the degree of the numerator, which is always the largest exponent in the numerator, is 2. And the degree of the denominator, if you don't see the degree next to x, you should know that it's 1, is 1. Well, since the degree of the numerator is greater than the degree of the denominator, it turns out there are no horizontal asymptotes. And that's exactly what we just said here. Since 2 is greater than 1, this rational function does not have a horizontal asymptote. Now you might ask the question, what happens when the degrees are the same? Well, it turns out if the degree of the numerator is equal to the degree of the denominator, then there'll be a horizontal asymptote at y equals a over b. Well, what does that mean? Take a look at our function here. Notice that a is the coefficient of the leading term in the numerator, and b is the coefficient of the leading term in the denominator. In our case, we made the 2 degrees equal. So it turns out that the horizontal asymptote would be y equal a over b. Well, let's look at an example of this. So here's an example. Let's take a look. Notice the degree of the numerator. We find the largest exponent. It's not always the first term, but in this case it is there. Look at the degree of the denominator. Notice that the largest exponent is, in this case, the last term. And that's also a 3. So since 3 is equal to 3, they're the same. It turns out there's a horizontal asymptote at y equals a over b. Well, what is y equals a over b? Well, a is the coefficient of the leading term, which is -4. So a is equal to -4. And b is the coefficient of the largest term in the denominator, which is 11. Therefore, there's got to be a horizontal asymptote at -4 over 11. To summarize that, which I did just below, the degree of both the numerator and denominator is 3, as we just said. Therefore, this rational function has a horizontal asymptote at y equals -4 over 11. Okay, so we've taken care of when the degree of the numerator what is less, the numerator is less, when the degrees of the numerator and denominator are equal. So now let's look what happens when the degree of the denominator is actually the larger one. So it turns out that when the degree of the denominator is larger than the degree of the numerator, so the degree of the denominator is less than the degree, oops, I misstated that. It should be the degree of the numerator, and we just fixed that. So the degree of the numerator is less than the degree of the denominator. Then there's a horizontal asymptote at y equals 0. So let's look at an example of that one, and here it is. So notice in this case the degree of the numerator is 4. The degree of the denominator is 7. So clearly the degree of the numerator is less than the degree of the denominator. So since 4 is less than 7, we know that there's a horizontal asymptote at y equals 0. And just to summarize that, once again, the degree of the numerator is 4, and the degree of the denominator is 7. And since 4 is less than 7, this function has a horizontal asymptote at y equals 0. Okay, I hope that's clear, because now it's your turn. So for each rational function below, we want you to find any horizontal asymptotes. If you're having any trouble with this, just go back, review the screencast, review the rules for how you can find horizontal asymptotes for rational functions. We're going to need this shortly when we start to graph horizontal functions. I hope this was helpful. Good luck, and see you again next time.